Assalamu alaikum everyone. Welcome to Maths Magic Hub. In this video, we will discuss the scalar product or dot product of two vectors. Well, when the product of two vectors is a scalar quantity, then that product is called a scalar product. Note that the scalar product of two vectors A and B is a real number. If A and B are two vectors, then their scalar product can be defined as A dot B is equal to A mod B mod cos of theta, where theta is the angle between two vectors. Note that either both vectors are directed away from a point or both vectors are directed towards a point. To make sure that you do not make any mistake in the exams, please note this property carefully. Always draw a sketch for both the vectors to make sure that either both the vectors are directed towards the common point or directed away from the common point. Some properties of the scalar product: parallel vectors, that is when theta equal to 0 degrees or 0 radians. If two vectors A and B are in same direction, that is angle between them is 0 degree or 0 radian, then in that case A dot B is equal to A magnitude B magnitude cos 0. Since cos of 0 degree is equal to 1, so A dot B becomes equals to A mod B mod. The self-scalar product of a vector, the scalar product of a vector with itself, that is A dot A, is equal to A mod cos 0 is equal to A mod square. So we conclude that the self-scalar product of a vector is the square of its magnitude. Perpendicular vectors, when theta is equal to 90 degree or pi by 2 radians, that is when two vectors are perpendicular to each other, then A dot B is equal to A mod B mod cos 90. Since cos of 90 is 0, so A dot B is equal to 0. Algebraic form of scalar product. If we are given vector A and B in terms of their components, that is, let us suppose A vector equal to A1 I unit vector plus A2j plus A3k, and B vector equals to B1 I unit vector plus B2j plus B3k, then their scalar product can be computed as A dot B equals to A1 B1 plus A2 B2 plus A3 B3. Next, we will discuss some applications of scalar product. Application number 1, we can use scalar product to find the angle between the two vectors A and B. The angle between the two vectors can be calculated by using the formula cos of theta equals to A dot B divided by A magnitude into B magnitude. Application number 2, we can use the scalar product to find the angle between the two lines. In order to find angle between the two lines, let us consider B vector and C vector be the direction vectors of the lines. Then the angle between B vector and C vector will be the angle between the given lines. So angle between the lines theta can be calculated. Cos of theta is equal to B dot C divided by B mod C mod. Application number 3, two vectors are perpendicular if and only if A dot B equals to 0. This is very important application of the scalar product. The phrase if and only if means if A dot B equals to 0 for two vectors A and B, then the vectors are perpendicular. And if the vectors are perpendicular, then the dot product A dot B will be equals to 0. Next application is also a very important application. Shortest distance from a point to a line. Suppose we have a line r vector equals to a vector plus lambda times b vector, where a vector is the position vector of some fixed point on the line, b vector is the direction vector of the line, and lambda is a parameter. Let us take a point P which is not on the line, because if point P is on the line, then its shortest distance from the line will be 0. So if the point P is not on the line, let F be the point on the line which is closest to the point P. This point F is sometimes called foot of the perpendicular. Next, how we will find the shortest distance? First, we will write the point F in terms of the parameter lambda. We will write the coordinates of point F in terms of the parameter lambda. Watch video number 2, lecture number 2 to check how to write, to learn how to write the point F in terms of the parameter lambda. Next, we will find the vector PF by using the relation PF vector equals to OF vector minus OP vector. That is subtracting the position vector of P from the position vector of F. Since PF vector is perpendicular to the line, so PF vector is also perpendicular to the direction vector of the line, that is PF dot B equals to 0. From this expression PF dot B equals to 0, we find the value of lambda. Next, we will put this value of lambda in the vector PF. This will give us the vector perpendicular to the line and length, and from P, and starting from point P and ending at the point F. The length of this vector PF vector will give us the shortest distance of P from the line. In some time we are asked to calculate the coordinates of the foot of the perpendicular, so we just plug in the value of lambda in the point F to get the coordinates of the foot of the perpendicular. Next, we will give some maths magic points of the topic. Maths magic point number 1: scalar product is commutative. That is A dot B equals to B dot A. So it doesn't matter you calculate A dot B or B dot A, both will give you the same real number. The result of both A dot B and B dot A is same, is equal. Maths magic point number 2: always draw a sketch to make sure you choose correct pair of direction for scalar product. Maths magic point number 3: perpendicular distance of a point from a line is its shortest distance from line, sometimes referred as length of the perpendicular. So if examiner asks to calculate the length of the perpendicular from P to the line, then basically we have to calculate the length of the vector PF already discussed. That's it for this video. For getting more videos, do subscribe Maths Magic Hub. Thank you for watching. Hope to see you in next video.